Okay, so we're still in chapter 3, of course. We're in section 7, and remembering that chapter 3 is mostly about molecules. We're dealing with how to, or rather, we're appreciating how to deal with molecules. We talked about symbols, we talked about what they look like, what does the term molecule mean. Right now we need to talk about how to measure them. So, and section 7 is entirely dedicated to formula mass or molar mass or molecular weight or formula weight or whatever. So molar mass, some textbooks might use like a script M for molar mass. Molecular weight is what I called this for the first 10 years that I used it. Formula weight's what I've been calling this for the last 10 years. And formula mass, I've never seen it called formula mass, I think, except by Tro. But let me point one thing out before we move on. Formula mass is generally going to be the mass or weight of one molecule, if it's covalent, or one. Remember what we used, the term we used for ionic compounds? Instead of molecules, we said it was one formula unit, okay? That's the mass of one. That's what a formula mass is. The molecular weight, we almost always are going to call that the mass of 1 mole, right? So this is typically, the formula mass is typically in AMUs, and this is typically in grams or grams per mole, right? Okay. So again, before we jump into this, let me remind you that 1 AMU is a really small unit. It's about 1 times 10 to the negative 27 grams. So 1 AMU, but this converts to 1 gram per mole. Okay? So we're going to go back and forth between these two very smoothly, but it's going to be so quick that you might not realize what we've done. So an AMU is very small. It's about 1 or 2 times 10 to the minus 27. I said grams. It's really kilograms, okay? And then 1 gram per mole is, well, 1 gram, right? This is not equal, sorry. The next thing is 1 gram. Okay, so let's move on. I think those will make much more sense if we look at some examples. Okay, so first of all, remember that when we're dealing with a molecule of something, this is a table from page 83. When we're dealing with a molecule of something, we're dealing with this many atoms, not this, right? That's the empirical formula. So if I said benzene, I guess if you'd have to know that benzene was C6H6 or it had these molecules in it. This was a structural formula. Remember, this was an empirical formula. This was a molecular formula. Remember this? This was a structural formula. Okay, we call this ball and stick. And this we called space filling. Good to look at those and ask yourself what's going on here, okay? So what we mean is, if we're talking about the mass of this compound, benzene, we're going to have to add up the mass of carbon, plus another carbon, plus another carbon, plus another carbon, plus another one, plus hydrogen, plus this guy, and so on, right? So we look up in the periodic table and we find that carbon is 12.011. Each carbon atom is 12.011 AMU. And a hydrogen is 1.008 AMU, right? Okay. So in order to calculate this, what we're going to do is we're going to take, we've got 6 of these, so it's going to be about 6 times 12, right? It's really 12.011, plus, how many hydrogens do we have? 6, right? So it's 6 times 1, which is going to be 72 plus 6, which is going to be 78 grams per mole. Oh, that's if you have a, yeah, I just did that. I did that by force of habit. It's really, this one molecule is going to be only 78 AMU, right? But we're typically not dealing with only one atom or rather one molecule. We're typically dealing with a group of them, so we would say it's 78 grams per mole. These two are the same thing. 78 EMU, 78 grams per mole. Okay? What about acetylene? Acetylene, it's got the same empirical formula, right? But it's got 2 carbon atoms for every molecule and 2 hydrogen atoms for every molecule, so it would be 2 times 12.011. This is like I have up here, but I'm giving more precision here. Plus 2 times what? You tell me. 2 times 1.008, right? Okay. And so I'm going to pull my calculator out. 12.011 times 2 plus 1.008 times 2 gives 26.038. 26.038 AMU. That's how much one molecule weighs. Or we would say it's 26.038 grams if you have a mole of them. Okay? All right, so that's how we figure out formula mass or formula weight. And so let's look at another example. Calculate the formula mass of glucose. All right, so what is the formula mass of glucose? Again, formula mass is the mass of one molecule if it's covalent, or formula unit if it's ionic. So we're going to say, all right, well, this guy's got 6 carbons in it, plus 12 hydrogens, right? Here's my carbon, my hydrogens, plus 6 oxygens in it, right? So what I'm going to do is I'm just going to go to the periodic table and look this up. 0.011, 1.008, and 16.00, depending on what periodic table you're looking at. That's what you'll get. Okay, 6 times 12.011 plus 12 times 1.008 plus 6 times 16 equals 180.162 AMU, atomic mass units. Okay. Now, if the question said instead, calculate can you read my writing? The formula weight of glucose C6H12, slow it down, O6. What would you do? What's the difference between those two? Okay, I'm going to leave that question unanswered, but it's something I'd like you to figure out. Calculate the formula weight of glucose instead of the formula mass. Okay, you might want to rewind the video if the answer is not obvious, and go look at that. Okay, let's do another example. Okay, so an aspirin tablet contains 325 milligrams of acetylsalicylic acid. All right, I'll make some notes here. I'm already overwhelmed. It looks like the mass of acetylsalicylic acid, just making something up here, is equal to 325 milligrams. All right, of blank. Okay, all right. By the way, my first thought is I don't like this in milligrams because I'm dealing with grams in most of my things. I'm going to go ahead and change this to grams so that I don't have to worry about that later. Okay? We know that there's 1,000 milligrams in a gram, and so this is 0.325 grams of acetylsalicylic acid. Okay, so that's one less thing I'm going to do later. An aspirin tablet contains this many milligrams. How many ASA molecules does it contain? Oh no, okay, right. So, well, not sure what to do with this. Let's go ahead and calculate the formula weight or the molecular weight, and then we'll set something up and see if it becomes obvious, okay? So the formula weight is going to be, I'm going to get lost if I don't organize some stuff here. It looks like it's 9 times carbon plus 8 times hydrogen plus 4 times oxygen. Okay? Can you see how I'm getting that? That's probably the magic of this whole section. But it's really important, and I'm going to do this religiously. I'm going to set my equation up first. Then I'm going to look up in the periodic table what those masses are and put them in. I'm not going to try to do this in my head or come up with a new way each time. It's going to be the same way every time. 0, 0, 8, and oxygen is 16, I think, with the periodic table that you guys have. And so I'm going to pull my calculator out and calculate this. It looks like it's 9 times 12.011 plus what? 8 times 1.008 plus 4 times oxygen. And this comes out to be, is that right? Is that possible? 180? That's very close to the same as glucose. I'm going to calculate that again. We had this 180 just a minute ago, so I'm going to calculate it again. But it looks like it's 180.163 grams per mole. Grams of acetylsalicylic acid and grams of acetylsalicylic acid. Right, so I'm going to be able to go to moles right away by doing a conversion. In fact, that's what I'm going to do. I'm going to go to moles of ASA, because I can see I've got grams and I've got grams per mole, both of ASA, and so I'm just going to calculate moles right away. But before I do that, I've got to check this number again. I'm just going to come over to some other part of my paper and say this is about the same as 9 times 12 plus 8 times 1 plus 4 times 16. Right? 9 times 12 is 108 plus 8 plus 64. Gosh, I can't do that in my head. 8 plus 64 is 72. Yeah, that's it. This is correct. Okay. All right, so if there's some kind of if glucose I think was also, I think it was, I don't remember. We'll go back and look at that later. For now, this looks like this is correct. All right, now the moles of this then, the moles of ASA is going to equal the moles of ASA, right? And I've got, that's moles of ASA right there, over grams of ASA, because that's what I have, right? Times grams of ASA. You guys okay with me using ASA? Just made that up, right? I didn't want to write this whole thing out. I wanted the formula out. Easy to get lost that way. Okay, so let's see. If we set this up, get to a different pen color here. Come on, a different pen color. All right, let's just do it with red. So how many grams? What number goes right here? What number goes right here? It's this one, right? 0.325. 0.325 grams of ASA. What number goes right here? Looks like it's just 1, right? Because it's just that many grams per that mole. And this is 180. I'm going to slow it down here. 163. Okay, so let's do this. Let's take 0.325 divided by 180. It looks like this gives me 0.001803922004. That's what my calculator says. Now, how many sig figs do I have in this answer? This looks like this has 3 sig figs. This has 6 sig figs. Okay, that number is exact. So it looks like this is going to have 3 sig figs. So here's my 3 sig figs right there. 0.00180 is my answer. Or I might write that as 1.80 times 10 to the minus 3 moles. Okay, now that I've got my moles, and I did moles just because it was natural, right? This was just interpreting the question. Formula weight, I knew I needed formula weight because I was going from mass to a number, right? But the number here is molecules. And then since I had those two numbers, I just went ahead and calculated the moles. I'm going to box this, okay? Okay. Now the question is how many molecules? I think we oftentimes use a capital N for molecules. I don't really care what we use. Doesn't really matter. Okay, what I'm going to do is I'm going to go back to the way that I recommended that you solve these problems before, and that is if you don't have any idea what to do, you come over here and you write down the units. Molecules, the units of the answer, right? Oops, missed a C here. Molecules. Okay, now if you do that, somewhere in your solution you have to have molecules. I wonder if this is my computer which is making this such sloppy writing. Okay, can't be my hands. Now, but we actually have moles, right? We've got the moles. So we've got to ask ourselves, what conversion do you have that goes from moles to molecules, right? Aha, I remember this is Avogadro's number. We know that there are this handwriting is horrible, I gotta start over again. 6.022 times 10 to the 22 molecules for every 1 mole, right? And what's the number that goes here? 1.80 times 10 to the minus 3. Okay, so I'm going to take this times 6.022 times 10 to the 23rd, and I'm going to get my answer. The answer is how many molecules? I hope you've already calculated this. If not, pause the video, calculate it now, and make sure you get the same thing that I get. Okay, it ought to be a big number, right? It's a number of molecules, so it's 1.09. It's really 86, right? Times 10 to the 21 molecules. But we have to report this to 3 sig figs. Gotta go real slow. Pen's not keeping up with my handwriting. 1.09 times 10 to the 21. All right. Hope that's helpful. That's the last example from this section.